Okay, inscribed angles. Again, lots of circles. So first thing that we're going to talk about is this setup. So let's say this is the center of our circle. This is not a central angle. This is called an inscribed angle. An inscribed angle is when the vertex of your circle is, or your vertex of your angle, excuse me, is on the circle. So this angle we would say is inscribed. Okay, that is an inscribed angle. With an inscribed angle, like I said, the vertex is on the circle, and then it opens up to what we call its intercepted arc. So the arc that it opens up to would be this arc right here, and that is your intercepted arc. So an inscribed angle and an intercepted arc have a relationship, okay? When we learned about central angles, so you don't need to draw this, I'm going to show you. This angle here, how did that relate to the arc?
Angle of the, what's it called, the arc?
The arc? The what?
The angle, like, it was 90 degrees, so wasn't like the arc 90?
Okay, right. So the angle equals the arc,
Yeah.
right? So if this is 90 degrees, then this arc is 90 degrees, right? That's central angles. Today we're talking inscribed. Any guesses what relationship this arc might have with this angle? Does that look like a 90-degree angle? It's half, right? So we're going to cut the intercepted arc in half, and that will be the measure of the angle. And that's called the inscribed angle theorem. I'm not going to write it out, but I will write this. I will draw you a quick picture. Oh, that's not a circle. Sorry. Try it again. So the idea is this. If this is A, B, and C, we would say the measure of angle ABC is equal to half the measure of arc AC. Okay, so you take the arc, this arc here, and you cut it in half. So if this is X, then this would be 1/2 X for that angle. Okay. So what you're going to do with that, there's just going to be a lot of pictures where it's find the angle or find the arc. Okay. Your first example here. Shoot, that one's not see-through. That's okay. Bear with me. These pictures won't necessarily be drawn perfectly to scale. What you need to look out for in these is, do you have a diameter? Because if you have a diameter, that makes a big difference with what the measures of different arcs will be. In this case, they have not marked a center of the circle, so you can't just assume that you have a diameter, but we're going to say this is A degrees. Sorry, my stylus doesn't like to draw the degree symbol. That's horrible. Let's try again. It's a really big one. This is 56 degrees. This is B, and this is 52 degrees. Harry, will you put your hood down and put that?
What now?
Yeah, that's why.
Yeah.
Take those out, put that away, hang out with me. All right, so if this is our setup, and we're looking for what is the measure of A, and what is the measure of B. Any thoughts? Do you see inscribed angles and intercepted arcs? Let's start with B.
That seems like a 6.
It's a B. It's just messy because I wrote it real small.
Wait, I thought it's easier if we start doing A first.
You can start with A.
That's 2
You have the inscribed arc thing or angle with whatever the other point is over there.
Right, so this arc right here,
Oh, that's
right, is the intercepted arc for this inscribed angle. So if 56 is the arc, what is the angle?
Half of it.
Right, B is half of 56, which is what? Mental math. 28 degrees. Okay, so B is 28 degrees. Do you see how we can find A? You have a question?
Yeah. How do we know to get that blue highlight part?
Well, so that is listed as 56 here. So if we're looking for B, if you look at where B opens up to, this blue, that's the intercepted arc for B, right? It's where the angle opens up to. You take that arc and you cut it in half,
Okay.
okay?
The angle measuring 52 opens up to the 56 in the A.
Right,
56 plus A equals 52 times 2.
right. So if you look at this angle, the 52 has an intercepted arc of this. How big is that arc? 104, right? If you double the 52, you get 104 degrees for that intercepted arc. So we know that 56 plus A equals that 104. So then it's just a matter of take away the 56, and you get A is, what does that come out to? Thank you. Oh, I didn't draw that very nicely. I was looking at you instead of at the paper. So A is 48 degrees, okay? So you're looking for which arc opens to which inscribed angle. Questions on that?
Yeah, I did.
Yeah.
Why did we double 52?
Because this is half of this arc. So if 52 is half of it, then if we double it, that's the measure of the arc, right? The arc will always be double the angle. Okay, so what do we do with this one? Same type of problem here.
Is this still example number 1?
Yeah, it's the same type of thing. I mean, you're welcome to call it example 2 if you want, but I have a separate example 2 that has a bunch of pictures as well. And again, not perfectly drawn to scale, but use your imagination. It's good for you. All right, so let's say this arc AB is 106 degrees. Arc BC is 100 degrees. Arc CD is 90 degrees. And arc AD is 84 degrees. Okay, I want to know the measure of each angle. Angle A, angle B, angle C, and angle D.
Angle A is 50.
A is 50?
Yeah.
No, but I see where you're going. You're on the right track.
Would it be 90 plus 100?
95.
So it's half of the.
Right. So here's the deal. You're taking angle A, okay? So if we start with angle A, here's our angle. So my intercepted arc is arc BCD, right? This arc. So if that's my intercepted arc, what?
Why did we put that
Because it's where the angle opens up to, right? Here's angle A, goes from here
in?
over to here. So everything inside of there is my intercepted arc. So you're going to say angle A is half of that big arc, which is 100 plus 90. Okay, so half of 190, so angle A would be 95 degrees. Okay, so there's A. So move on to B. B opens up to what? 64 and 90, right? So this, the blue, is our intercepted arc. So angle B is half of 90 plus 64. So half of 154, which means angle B is 77. Are you seeing it?
Yes.
Yeah? Okay, let's do C and D, and then we'll do another one. Angle C. Sorry, I'm telling you, that piece of corn or black bean is just not sitting well. It just feels like, how does it get stuck right there? It's so weird. I feel like I'm gonna like cough it up one of these times. Sorry, watch out, front row. Okay, C, angle C opens up to 64 and 106. So here is your intercepted arc. Color coding works wonders on these, by the way. There's a lot going on. I mean, it works wonders for me all the time because I love color coding, but you know. So angle D is half of 106 plus 64. So it's half of 170.
Wait, that's C. It's not D.
Oh, sorry, D. Oh, I just did C.
It's okay.
We haven't done C. That's okay. Scratch this. Angle C. 106 and 64. That's what I highlighted. I just said the wrong letter. So half of 70 for angle C, you get 85 degrees. Okay, last one. Let's see. We need a new color. I love these. These are like my fave. Angle D. And I will try to do the right one this time. Here we go. D opens up here to here. So your arc,
106, 77, and 100.
no 77. 106, right? The arc is this. 106 over to 100 for angle D. So it's half of 106 plus 100, or half of 206. So angle D comes out to 103. Okay? Yeah.
Why don't we include B
Why don't we include what?
on B? Because that would be 77.
B is the angle, and we're not talking about the angle we have to cut in half. You cut the arc in half. So the arc is just this part. The angle that we found, 77, was that,
Okay.
right? So you just want the arc. Okay? Questions on that?
These are so cute.
So cute.
They're all.
Okay, here's something I want you to be aware of. Take note, because you're going to learn this corollary right now. Look at these two angles. And look at these two angles. And tell me if you notice anything.
If you add them, are they equal?
What do they equal? 180, right? When you add them together, they are supplementary. Notice where they are in the picture. So angle B was up here. Angle D is down here. Those are supplementary. Then angle A was here, angle C is here, and those are supplementary. So there's a corollary to the inscribed angle theorem that says if a quadrilateral is inscribed in a circle, then the opposite angles will always be supplementary. Okay, so they will add up to 180 in that situation, which I'm going to give you the three corollaries right now. So that's one that we can do. Let's see. We're just going to do this. Okay, so these are the corollaries, the add-ons, in other words, to the inscribed angle theorem. 3 things. And I'm just going to draw you 3 pictures and then kind of describe it in picture form as we go. So 1 corollary, 2 corollaries, 3 corollaries. All right, so the first one, the picture looks like this. We're going to call this angle 1 and this angle 2. And notice our arc here. Okay, the corollary says if 2 angles open to the same arc, what's true about those angles? They're equal. Those angles will be the same, okay? So 2 inscribed angles that intercept the same arc are congruent. Okay, in other words, angle 1 is congruent to angle 2 because they both open up to the same arc. Okay, so that's the first corollary. The second corollary says an angle inscribed in a semicircle. So if this is the center of our circle right here, and then I have this angle. Okay, so angle 1 here. That angle inscribed in a semicircle like this, right? You have a semicircle here. What will be true about that angle? It's 90, right? Because it's a semicircle, 180, so it's always going to cut that in half, so it'll be 90. So whenever you have an angle inscribed in a semicircle, is a right angle. Okay, so that's the second corollary. And then the third corollary is the one I just told you about. If you have a quadrilateral inscribed in a circle, so angle 1, angle 2, angle 3, and angle 4, what happens is angle 1 and angle 3 are supplementary. And angle 2 and angle 4 are supplementary. Okay, so it's always the 2 that are across from each other will add up to 180. And where I see the most mistakes made on that is people set them equal to each other. They're not equal. They have a relationship, but they are not equal. They are supplementary, okay? They have to add up to 180. Questions on that? Okay. Last few examples then. Let's say, so this is like example 2. This is our example 2. You have this circle. All right, so here's your picture. What's the measure of angle 1? 90. How do you know? Right, it opens to a semicircle. So the 70 and the 40 mean nothing to us. We don't need them. We're not using them. They are just there to pester you into thinking that you need them, but you don't. I know, not nice, right? But this one opens up to a semicircle. So that's why I say look for diameters. If you have a diameter, you have a semicircle somewhere, the angle inscribed in that, so this angle 1 is going to be 90 degrees because it opens up to a semicircle. Okay? Questions on that?
Yeah, can you go with that again?
Yeah, so you have the center of the circle here, right? Makes this a diameter, okay? Making this 180 degrees. So if that arc is 180, angle 1 opens up to that semicircle, making this angle 90. Okay? You're welcome. All right, what do you do with this one? No, that's not what I want. I want to know, what is x? 38. How do you know?
Because of there, it's trying to one same arc.
They have the same arc, right? So 38 here opens up to this arc. Okay? Well, x opens up to that same arc. And the corollary says if they open to the same arc, they are the same measure, right? If you did the work of it, this would be 76 degrees. Cut that in half to get x, and x is 38. But the point is, you don't have to do the work, right? You know that if they open to the same arc, they are the same number of degrees. Okay? All right, last one. Very similar to the other one that we already did. It's a very jagged diameter. All right, so here's angle 1. This guy's angle 2, angle 3, and angle 4. And we know this arc is 60 degrees, and this arc is 80 degrees. All right, let's start at 1. How many degrees is angle 1?
4 is 17.
A is what? Did you say A is something?
I know that.
Oh.
I go 4 is 17.
4 is 70, but you don't need 4 to find 1. How do you find 1?
And we find the
You can find the 2, but how do we find 1? You're jumping ahead of me, Scott.
What is 90?
Right.
Opens to the semicircle.
1 opens to the semicircle, right? This is a diameter. So if you have a diameter, you have a semicircle, meaning this arc here, right, is 180. So if that arc is 180, then angle 1 is 90 degrees. Okay, what's angle 3? If angle 1 is 90, angle 3 has to be 90. Why? Because they're supplementary, not because they're equal, right? It's because they are supplementary. So angle 3 is 180 minus 90, so angle 3 is 90 degrees. Okay? All right, Scott, how do you find 4?
just to cross 60 and 80.
Right. So 4 opens up to this arc, which is 60 and 80 put together, and then we cut that in half. So 60 plus 80 cut in half gives you angle 4 is 70 degrees. So if angle 4 is 70, right, if this one's 70, then 2 is what? 110. It has to be supplementary. So angle 2 is 180 minus 70, which is 110 degrees. Okay? Questions on that? Yeah.
Yeah, so what confused me was, I thought when it opened up, it would go, when the one opened up, it would go to the third.
It would go where?
To the third, because it looks like that's the next angle.
When one opens up, it's opening to an arc, not an angle, right? Angle 1 is here. So its intercepted arc is this. So I know that this portion is 80, right? This portion we could say, because we know it's 180, this portion then would be 100. This angle doesn't impact that arc.
Okay.
It shares a point, right? They share a point, but that's all they share. So you're not going to use an angle to find an arc. Well, you are, but you're not going to use an angle that's on that arc to find the arc. You're going to use the inscribed angle across the way.
I need to be careful of that, because I keep using angles instead of.
Yeah. And you'll use angles, just not ones that are on that arc. It'll be the ones across from the arc.
Okay.
Okay?